Today's lesson is 2-6, day 2, solving absolute value equations. It's very similar to what we did yesterday. We just want to make sure that you get an extra day of it to make sure that you get absolute value equations. Our objectives today, or our I can statements, are to be able to solve equations in one variable that contain absolute value expressions.
All right, we're going to look at the definition again of absolute value, but you don't need to write this down again because presumably you wrote it down last night. Just keep in mind that the absolute value of x is the distance from 0 to x on a number line. So again, absolute value measures distance. It can never be negative. It is always positive. X, the absolute value of x equals 5. That means that x is 5 units from 0, which means that x could be negative 5. Or x could be positive 5. And down here, the absolute value of x is 3, which means that x is 3 units from 0, which means that x could be negative 3 or x could be positive 3.
All right, our first example, and you do not have to write this one down because it's very, very similar to the 2-6, day 1. I just need for you to watch and listen. So number 1 is the absolute value of x equals 8. Again, since it equals a positive number, we're going to write two equations. And it says what numbers are 8 units from 0? Negative 8 and positive 8 are both 8 units away from 0. So again, we split this up and we say x equals negative 8 and x equals positive 8. So those are our two answers here because we don't have anything else to solve for to get x by itself. So we're going to write the solution set and list the numbers from least to greatest. These are our braces or our squigglies. So it's negative 8 and 8. And again, those numbers need to be in order from least to greatest. If I go through to check these numbers, and again I go back to my original, instead of x, I'm going to put in negative 8. So it's the absolute value of negative 8 equals 8. Absolute value turns everything positive, so the absolute value of negative 8 is a positive 8, and 8 equals 8. Then I'm going to put in my positive 8. The absolute value of positive 8 also equals 8, so 8 equals 8. So both negative 8 and 8 are solutions to our absolute value equation.
We're going to look at number 2, and again, you're not going to write this down. You have the absolute value of n minus 5 equals 1. So because our absolute value bars are isolated on this side of the problem, we're going to go ahead and set up two separate equations. We have negative 1 and 1. It says write two equations. What numbers are 1 unit from 0? Both negative 1 and 1 are 1 unit from 0. So you have n minus 5 equals negative 1 and n minus 5 equals 1. We have to isolate our variables, so we're going to add 5 on both sides, which gives us n equals 4, and then on this side we're going to add 5 on both sides, which gives us n equals 6. We're going to write our answer in our braces or our squigglies in our solution set from least to greatest, so starting with 4 and then 6, because both 4 and 6 will make this sentence true. We're going to check just to make sure that we did that correctly. We're going to plug in 4 for n here into the original problem up here. 4 minus 5 is negative 1, and the absolute value of negative 1 is 1, and 1 equals 1, so that checks out. Over here, we're going to plug in a 6 for our n. So we have 6 minus 5, which equals positive 1, and the absolute value of positive 1 is positive 1. So 1 equals 1, and that checks out as well.
If the absolute value expression is not isolated, you will need to do that step first. That means if the absolute value bars have anything around them, you need to move that first. So if there's a number in front of the absolute value or adding or subtracting something from the end of the absolute value, you need to get rid of that before you set up your two equations. Here's our first one. Go ahead, and you do need to write this one down, so you're going to start writing down with number 3. It says 5 absolute value of x minus 1 and then plus 9 equals 24. So again, I need to get the absolute value bars by themselves before I do anything else. So here's my absolute value bars. I've got a 5 in front, which means that it's being multiplied because it's right next to it. And I have a plus 9 over here on the end. So we're going to move that plus 9 first. And to move a plus 9, you're going to subtract 9 from both sides. Just like you would a regular equation, we're going to move the adding and subtracting before we move the multiplying or dividing. So I go ahead and bring down 5 absolute value of x minus 1, and that equals 15 because 24 minus 9 is 15. Then we need to move the 5. And again, since the 5 is right next to the absolute value bars, it's being multiplied. So we're going to do the opposite, and we're going to divide both sides by 5. Again, absolute value bars are not the same thing as parentheses, so you cannot distribute here. You need to divide both sides by 5 to get rid of that. So my 5's here and here cancel, and I bring down my absolute value of x minus 1. And then 15 divided by 5 is 3. Once my absolute value bars are by themselves, I'm going to look over to the right-hand side. Since this is a positive number, I know that I'm going to have 2 solutions. So I'm going to set up 2 different equations. And again, it says what numbers are 3 units away from 0, -3, and +3. So when I set this up, I'm going to say x minus 1 equals -3, and x minus 1 equals a +3. We're going to solve each one of these. This one I'm going to move minus 1 by adding 1 to both sides, and I get x equals -2. On this side I'm going to add 1 to both sides, and 3 plus 1 is 4, so x equals 4. So our 2 answers are -2 and 4. We're going to write our solution set and list the numbers from least to greatest in our braces, or as I like to call them, our squigglies. They need to be in order from least to greatest, so -2, 4. Make sure that you have all of this written down. Now we're going to go ahead and check just to make sure. Since we have 2 solutions, we do have 2 different checks. You go back to the original equation before you move the 9, before you moved anything, back to the original. Instead of x, I'm going to plug in a -2. And from here, it's just order of operations. So we're going to do what's inside the absolute value bars first. -2 minus 1 is -3. And then I'm going to say the absolute value of -3 is a +3, because absolute value turns everything positive. And then 5 times 3 is 15. 15 plus 9 is 24. So 24 equals 24 works, so -2 is a correct solution. Then we're going to check 4. We're going to say 4 minus 1 is 3. The absolute value of +3 is 3. And then 5 times 3 is 15, and 15 plus 9 is 24. So again, that works out as well. So -2 and 4 are our solutions to this absolute value equation. So go ahead, take a minute, make sure you have all of the work written for this. Make sure that you have both of the checks as well. You do not have to have the number line at the bottom.
All right, we're going to look at the example 4 on paper. This is your equation. You have -2, absolute value of x plus 3, and then you're going to close your absolute value bars, plus 6 equals -8. So go ahead and get that problem copied down before we move forward. Our first goal is going to be to isolate our absolute value bars, and this one looks a whole lot like the one you just saw. So we have this -2 being multiplied by the absolute value bars, and we have this +6 being added. So again, the first step is going to be to subtract our +6 before we divide by -2. So we're going to subtract 6. This cancels, and over here it gives me -8 minus 6, which equals -14. And I'm going to bring down my -2, my absolute value bars, and my x plus 3, my equal sign. So now I have to divide both sides of the problem by -2 to get this -2 to cancel. So I'm going to divide this by -2, which cancels that. And I'm going to divide this by -2, which gives me a +7. So the absolute value of x plus 3 equals 7. Now that my absolute value bars are isolated, I'm going to set up 2 different equations. So because I'm looking at absolute value in units away from 0, I have -7 and +7. So I'm going to drop my bars and say x plus 3 equals -7, x plus 3 equals +7. So I subtract 3, this cancels, and that gives me x equals -10. I'm going to subtract 3, this cancels, and 7 minus 3 gives me +4. So in my squigglies, or my braces, I'm going to write my solution set from least to greatest, -10, 4. And again, just do the best you can on drawing those. Now, because we have two answers, we have to check two answers. Make sure that when you check, you come back to the original problem. So I've rewritten the original problem up here so we don't have any confusion about what we're plugging into. We're going to plug in our negative 10 first. So I have negative 2, absolute value negative 10 plus 3 plus 6 equals negative 8. So the first thing I'm going to do is what's inside my absolute value bars. That gives me a negative 7. So I'm going to leave it in those absolute value bars. And I have negative 2 times the absolute value of negative 7 plus 6 equals negative 8. So now I'm going to go ahead and get rid of my absolute value bars, which turns my 7 positive. So I'm going to change it to parentheses. And now I have negative 2 times 7, which gives me negative 14 plus 6 equals negative 8. And negative 14 plus 6 does equal negative 8. Negative 8 equals negative 8. So my negative 10 here is a solution for this equation. So now let's look at our 4. Again, I'm going to go back to the original problem and plug in a positive 4 everywhere I see an X. 4 plus 3 is going to give me 7, the absolute value of 7. The absolute value of 7 is just positive 7. Negative 8, not 18. Negative 2 times 7 again is going to give me negative 14 plus 6 is negative 8, and that is negative 14 plus 6 does give me negative 8. Negative 8 equals negative 8, and this checks out. Make sure that you have all the work and the check written down before you move on.
Right, just like we talked about yesterday, absolute value equations either have two solutions, one solution, or no solutions. And after we get those absolute value bars isolated or by themselves, we can tell how many answers or solutions that we're going to have. And it says not all absolute value equations have two solutions. If the absolute value expression equals 0, there is one solution. And if an absolute value states that an absolute value is negative, there is no solution because absolute value turns everything positive, so there's no way to get a negative number. You do not have to write this down because you should already have it written down from yesterday. So again, if the absolute value equals a positive number, you're going to have two solutions and two solutions to check. If the absolute value bars equal 0, you're only going to have one solution because again, you wouldn't split that up and say positive 0 and negative 0 because there's no such thing. And here, if the absolute value bars equal a negative number, it's going to be no solution. We like those because if there's no solution, then there's no solution that we have to check. Go ahead and write down number 5. It says the absolute value of x minus 4 plus 10 equals negative 10. Now, if we look at this, we have a tendency to go, oh, well, there's a negative, so there's no solution. That's not true. We have to get the absolute value bars by themselves before we can determine how many solutions we're going to have. So I have to move this plus 10 that's on the outside of the absolute value bars first. So I'm going to subtract 10 from both sides. Negative 10 plus 10 gives me 0. So the absolute value of x minus 4 equals 0. Since the absolute value bars are by themselves and it equals 0, that means I'm going to have one solution. So I'm going to go ahead and just set this up and say x minus 4 equals 0. Again, I don't want to split it because positive 0 and negative 0, again, there's no such thing. 0 is just 0. So x minus 4 equals 0. I'm going to add 4 to both sides to get the x by itself, and x equals 4. So 4 is my only solution here. We're still going to write it as a solution set in our braces, or squigglies. Since we only have one answer, that means that there's only one answer to check here. The only thing that we're going to check is the 4. So we're going to go back to our original equation. You should have went back up here, although our check didn't do that. It just says 4 minus 4 is 0, and the absolute value of 0 is 0. I would rather you go in and put it in up here, and then say that 0 plus 10. Okay, just go from here and write down this part of the check. Take a minute, make sure you have the problem and the check written down. All right, guys, we were looking back at number 5 and trying to figure out why it wouldn't check if you went back and plugged it into the original, and we actually had a typo on here on number 5. Please make sure that you go back and change this to -10 instead of +10. That way, when we do add 10, that is the correct thing to do. So go back, that was just a typo on our part. Go back to number 5 and change that to -10 instead of +10. And then it should work if you plug it back into the original, because 4 minus 4 is 0, absolute value is 0, 0 minus 10 is -10.
All right, let's look at number 6. The first thing we have to do is get our absolute value bars by themselves, isolated on this side of the problem. So we're going to subtract 5 from both sides. When we subtract 5 from both sides, that gives us the absolute value of 2x equals -2. Now, over here, you can see that your absolute value bars isolated over here are equal to something negative on this side of the equal sign. Absolute value can never be negative. There are no negative solutions. The absolute value cannot equal something negative, so there is no solution. So that's all you need to write for number 6. Just make sure that you have this work down and that you get it to this point where it says the absolute value of 2x equals -2, and then write the words no solution, because that is the correct answer for this problem. Number 7, we want you to pause the video and try to work this one on your own. We've done some more complicated ones than this so far today. Go ahead and pause the video. Remember, your first goal is to isolate the absolute value bars and then break it down into 2 separate equations. All right, you should have paused the video and worked this one out on your own, but we're going to go over it together just to make sure you didn't make any mistakes. We're going to add 6 on both sides in an effort to get our absolute value bars by themselves. And -1 plus 6 gives me +5. So now my absolute value bars are by themselves, so I'm going to set up 2 separate equations, and I'm going to drop the bars. I'm going to say 4x plus 3 equals -5. And 4x plus 3 equals +5. I'm going to subtract 3 on both sides to get my 4x by itself. And -5 minus 3 gives me -8. And over here, 5 minus 3 gives me +2. Now I have to get my 4 away from my x, so I'm going to divide both sides by 4. This gives me x equals -2, because -8 divided by 4 gives me -2. And over here, I'm going to divide by 4. See, that cancels. That cancels. And it gives me x equals 1/2, or 0.5. So least to greatest in my squigglies, I'm going to write my solution set, and I have -2, comma, and I'm going to use 0.5 for this one because that's what I use in my check. All right? Now, I wanted you to try to check this on your own. If you have not already tried to check this on your own, go ahead and try to do that now. You can pause the video, and then I'm just going to show you the check instead of walking you through it. All right, so this is what your check should look like for that problem. Again, we went back to the original problem and we plugged in -2 for x, and then down here we plugged in a 0.5 for x. And you should have gotten that -1 equals -1, and again, -1 equals -1.
If you made any mistakes with that check, please go back and fix that now.
All right, so back to our objectives for today. Our I can statement, you can now solve equations in one variable that contain absolute value expressions. We're going to give you 2 before you go problems. We want you to take the time to work these out and see what you can do on your own before you look at the work. Pause the video now and take some time and work out each of these problems. All right, this is your work for these problems. This is what you should have. Number one, when you isolate the absolute value bars, you end up with a -5 on this side, and your absolute value can never be equal to anything negative, so there is no solution. Make sure, if you didn't get this, make sure that you subtracted your 2 and then divided by -1. That's the most common mistake here. Make sure that you did not say 2 minus 1 equals 1, because that you can't do that. This -1 is being multiplied or distributed times everything in the absolute, no, not distributed, sorry, my fault. Go ahead, explain it.
Okay, you have to subtract the 2 because, again, the -1 is being multiplied times the absolute value. So you can't go ahead and just actually subtract those. You have to subtract the 2 first and then divide everything by -1.
Okay. All right. Sorry. And number 2, just make sure that you got your single answer, which is a +4, because your absolute value bars were equal to a 0. And anytime absolute value bars are equal to 0, you have one solution, so you should have checked your one solution down here and got -6 is equal to -6.
If you have any questions, feel free to ask those tomorrow if you didn't get one of these correct and you can't figure out why.
This is the end of your video. Thank you for watching.